Assalamu alaikum. With the name of Allah who is most beneficent and merciful. So today I will discuss a topic from plain reinforcement concrete. The topic is how to calculate the dead load of a member or a structural member. Let's take an example that we have a beam of width B and height H, and we are going to calculate the dead load of this beam. So the formula is B into H into gamma. B is the width of this beam, H is the height of this beam, and the gamma is density of which material the beam is composed of. The density of different materials is given in standards. The density for PCC is 2300 kgs per meter cube. It is for RCC 2400 kgs per meter cube. For brick tiles it is 1930 kgs per meter cube. So we can also convert the units of this density of RCC from kgs per meter cube to kilonewton per meter cube. We have to multiply it with 9.81 and divide it with 1000. So it will approximate 23.6, and it will come in the units of kilonewton per meter cube. And similarly, if we multiply this density 2400 kgs per meter cube with 2.205 and divide it with 3.28 cube, so we will get the result in lb per feet cube. So these are the unit conversions that we have to face during the calculations. So now it is all about that how we can calculate the dead load of a structural member. By using this formula, we have given the densities of all the materials that we use in our construction industry. So by putting the density, by putting the width and the height of that member, we can calculate the dead load of the member. And the live load is given in standards. We can't calculate the self load or the live load of the member. So by using 20% dead load and 60% live load, we can calculate the factor load that must be used in design of the member. So the next question in this video is why steel is preferred as compared to other materials. It's a very important question that there are a lot of materials in our construction industry, iron and a lot of materials, but why we use steel in RCC structures in place of other materials? The reason is very technical. That the first reason, a very solid reason for this is steel has ductile behavior on failure. When the steel breaks, it shows a ductile nature because it will give a warning before failure. When a steel specimen is tested in universal testing machine, then the stress strain curve obtained after the as a result is just like this curve, in which there are three different zones. This first zone is known as proportional zone, in which the stress is proportional to the strain, and then the yielding zone will start, and the yielding is a process in which the stress is constant and the strain kept moving. After the yielding zone, strain hardening zone will start. In strain hardening zone, this maximum point is known as ultimate strength, and it is also shown by a sign of Fu. And this is a breakage of the steel specimen. So here we can see that this is the yielding and this is the strain hardening zone, but the capacity of the steel, the strength of the steel that we use in the design is Fy, yield stress. It is also known as yield stress. So this is a value that we use actually in the design. So from this value to this value, that is the ultimate strength, this is all about the factor of safety. This is all about the warning that the steel gives before failure. So it is the first reason that we use steel as compared to other materials. For example, if you draw the stress strain curve for iron, then the curve is just like here. So we can see that iron gives no warning before failure, and that is not good for the structural members. So in this way, the point 1 is very clear that steel has ductile behavior on failure. Hence we use steel as compared to other materials just like iron. The next point is steel and concrete has same contraction and thermal properties. So these are the two reasons for which we prefer steel in place of all the other materials. So thank you.